Okay, shall I start? All right. Hello, everyone. This is Mo from Celer. It's great to be here and happy to talk a little bit more about what we are building in Celer, a multi-chain operating system. So I think at this point, like, there's no doubt the future is definitely multi-chain. We started from this one smart contract blockchain, which is like mainly Ethereum. But over the last 2 years, what we have seen is an explosion of multiple different kind of chain architectures. There are some layer 2 solutions that are building on top of the existing layer 1s, and there are a lot of alternative layer 1 solutions that is popping up in this space as well. So the reason for this kind of a multi-chain explosion is really because of the overall space demands like scalability, right? So like if you have an application that demands like 1 million daily active user and with high interactivity between different users in this application, one single blockchain simply cannot sustain, no matter how fast the underlying blockchain is. We have seen this repeatedly in the last couple of years. So the way to actually increase the capacity for this entire blockchain ecosystem is actually by increasing the number of chains, either via layer 2 or via layer 1. Now, this is all good, but at the same time, we know that this kind of scalability achieved by having a multi-chain infrastructure or multi-chain architecture is not actually free, right? So because now you have multiple different chains that are isolated from each other, you essentially have fragmented liquidity between different chains. And you also lost a very, very important factor between all the smart contracts in a single chain, that is composability. You cannot have a very easy way to have one contract be connected to another contract via smart contract calls if these two smart contracts are actually sitting on both chains. So what we are looking at right now is actually very, very complicated user experience, right? So like you have one user, SushiSwap is a great example. SushiSwap is probably now on 18 different chains, and you have SushiSwap, and the user, when using SushiSwap, need to manually switch between different chains. And for each SushiSwap instance, you probably always see this kind of USDT, USDC liquidity pair that is repeated across multiple chains. This actually fragments the entire liquidity so much that you don't actually have a very good slippage on every chain. Like, but you could, if you could somehow merge all this liquidity together, you could actually have very, very good pricing for certain pairs, right? So it's a really kind of a bad situation right now. Now, the question now is, okay, we get scalability, but we are trading off a lot of these things that we just mentioned. How do we kind of buy back those things that we trade off for scalability, right? So how do we represent to the user still with a very, very simple user interface, and also at the same time allow application developers to build application that can share states between all the different chains, share liquidity between all the different chains, and have this kind of a home, a layer on top of all these different blockchains to coordinate all of the liquidities and states together. Now, there's a famous saying in computer science that is one layer of abstraction solves literally every computer science problem. And the history actually rhymes in this particular case, because in a way, we're actually stepping into a multi-core era for the entire blockchain space, right? So like, if you remember in 2000, early 2000, we still have like just only a single core CPU, but then we start to have a multi-core expansion. If you treat each of the compute core in CPU like a blockchain, where essentially if we're treating this entire kind of a blockchain ecosystem as an entire compute unit, then we're essentially entering the multi-core era. And in multi-core era, the architecture is actually pretty simple, that you have a shared memory and also communication bus Let's connect all these kind of different cores, and in this case, blockchains together, so that they can actually coordinate in a very efficient way instead of operating in an entirely isolated fashion, right? So now this is basically, what Celer is doing here is providing this kind of a multi-chain operating system capability. Now, I want to emphasize here that Celer is not just providing a message passing layer. That is like, you can have one message or one function call starting from one chain goes to the other. This is cool, and Celer can support this. But Celer is not only about that. It's way beyond that. Like it's having the capability to have a cross-chain logic that are built into this operating system layer. So this cross-chain logic can actually look at all these different chains and synthesize the states that's available on all the chains and make decisions and transform messages passed from one chain to another. So in a way, the Celer network as a whole is treating each and every individual blockchain as as a smart contract or as an application. So like it's actually a coordinating point that can run complicated logic inside of the Celer protocol. And we're gonna discuss about that and with some examples as well. So, but how does that work? Like from a flowchart perspective, step by step, let's guide through the working process here. So the first thing is like user will start from source chain. The idea here is that a user doesn't have to interact with multiple different chains to interact with applications and access states and liquidity on multiple different chains, right? So, the user can just start from source chain and send one transaction, in this particular case, this A here, to the dapp plugin, and the dapp plugin can interact with the dapps in the chain A. And after the interaction, the dapp plugin can send a message to essentially a message bus contract. This message bus contract can emit an event that is going to be collected and monitored by something called a state guardian network. I will talk about state guardian network a lot more. But what state guardian network is a Cosmos-based blockchain. So we're essentially kind of running a blockchain on top of all these different blockchains. The state guardian network will reach consensus, first of all, using the Cosmos-based, the Tendermint-based consensus on the fact that this message actually happened. And at the same time, it will generate a multi-signature attestation, and also run a cross-chain logic on top of this message. So this is where Celer is really different from all the other kind of cross-chain message interoperability solutions, is that there's additional smart contract logic that can be run on top of SGM, because SGM itself is actually also a smart chain. And then after the logic gets processed and the message can be passed out in a multi-signature fashion. And this is not just simple POA multi-signature, it's actually a proof of stake multi-signature that is assigned weighted by stake. And the message will send to an executor, and the executor can relay this message to a message bus contract on the destination chain. And the message bus contract on the destination chain can interpret this particular message and call corresponding smart contract that user wants to actually call in the very beginning. So from an application perspective, there's logic on the source chain, there's logic on the destination chain, but most importantly, there's logic actually in the state guardian network, which is very, very different from just a simple message passing layer. So what you can do with this is some application like this, where you can have Ethereum on Arbitrum, and you want to swap to BNB on BSC, and all of this swap can happen while you're connected with only Arbitrum and with one transaction on Arbitrum, and you can just swap your token on Arbitrum to the BNB token on BSC chain, all in one transaction. There's like no need to have like multiple different transactions or manual bridging and everything like that. So, and an application that we built, recently is called a C-Bridge. So C-Bridge is an asset bridge that's built on top of the Celer's multi-chain operating system. So it exemplifies exactly that, right? So like in C-Bridge, there's a liquidity pool-based bridging model where liquidity providers pool their liquidity on each and every different chains. And when the user bridge fund from one chain to another, he's essentially adding liquidity on one chain. and removing liquidity from liquidity pool on the destination chain. Now, the interesting question to solve is like, how do you determine the pricing curve between two different chains? If what happens if the supply or liquidity pool on one chain get exhausted? Like, do you still just do one pricing? Well, no. So this is where the SGN becomes super powerful. Here is that the state guardian network actually implement the pricing curve based on the available information regarding the liquidity pool balances on each and every chain. So when the user is sending is effectively the message saying that, okay, I have put $5 into this liquidity pool on BSC side. What is the liquidity that I can get from Ethereum? So that computation can actually happen in the state guardian network chain without complicated message passing between local smart contract, and without things like a reservation of capacity and very complicated computation like that. So the C-Bridge has been growing rapidly. Just to have a quick overview in terms of like C-Bridge statistics, we have C-Bridge to date have processed more than $6 billion transaction volume for 130K users. On daily basis, it processes about 60 million daily volume for 27 different chains, and so far it has collected $5.2 million protocol fees, and roughly speaking, there are $790 million total value locked with 85 different tokens supported. So the C-Bridge side is definitely growing rapidly, but it's just as a first application for the Celer's multi-chain operating system. While a lot more exciting things like cross-chain swap, cross-chain DEXs, cross-chain lending protocol, cross-chain governance are actually being built by on top of the Celer multi-chain operating system. So there are some kind of a more technical detail here, but the high-level idea here is that every Celer's interchain message protocol is actually fully composable, in the sense that if you build an application on top of a Celer's interchain message protocol, and you have the capability to compose that with some other applications built on top. So it's almost like a smart contract chain itself. So for example, you can have a application that says, okay, I want to send $100 from source chain to destination chain via C-Bridge. C-Bridge is the application built on top of Celer Network, and then you can say, okay, but with that $100, I want that $100 to do something on the destination chain. I want to use that $100 to buy, let's say Ethereum or buy BNB. So that logic can be augmented on top of this fund transfer. So like you can actually have full composability between applications built on top of Celer Network's technology. So now let's discuss like the most important topic here is like, so SGN seems to be the beating heart of this entire construct. It is passing information. It is running smart contract logics. So what is SGN? Like, how is that secure? Well, so for State Guardian Network, it is a tendermint consensus-based blockchain with POS staking happens on Ethereum. So it immediately provides the same layer one level of security, just like Cosmos Hub, just like BNB Chain, just like Polygon, and all these other different chains utilizing the tendermint-based construct. And then basically in this construct, like if one of the validator become malicious, if the minority amount of validator become malicious, this validator will be noticed by all of these other validators, and his stake, which is his Celer stake, will be slashed, and he will be kicked out of the validator system. So essentially, it's the same thing for any proof of stake network. Now, what happens? You say, like, what happens if all the validators are actually malicious? Well, this is where Celer is also very unique. That Celer comes with two different security models for developers to choose, and for developers to choose for each actually transaction, right? So like, even if the assumption is that the majority of the validators can be malicious, what we also provide is a two-phase commit or optimistic rollup like a security model, where you have a time buffer in the destination chain when the message is passed to the destination chain. So whenever a message arrives, the message need to be sitting in this quarantine zone for some time. And during that quarantine time, the application guardian and each and every state guardian network node can cross-verify the message being passed between source and destination chain. If the application guardian decides that, okay, this information seems to be a malicious information that is passed by the state guardian network, the application guardian can actually throw the message to the garbage can, like basically cut the message from actually executing any effect or causing any harm. So this way, you're essentially trading a small delay of this time buffer, essentially in this quarantine time, with the enhanced security, where you're enhancing the security from a majority stake security to a you basically need without this kind of time buffer, you need like less than 2/3 of the validator's stake being malicious. But if you have this time buffer, you're essentially kind of enhancing the security model to trust any. And if any nodes in the state guardian network, or even just one application guardian is still honest, you can still have this full security maintained. So this is also very, very unique in Celer compared to all the other different approaches. And in practice, you can mix match different transaction to use different security model. Like if you want to have a low value transaction, you can perfectly find you relying on POS model in the beginning. And if you really, really are obsessive about like security, you can have high value transaction rely on this optimistic rollup based security model. So the final question is like, how is the token captures network value, right? So because Celer token is a staking token for Celer Network, and for every validators and delegators, when they stake Celer, they're essentially providing security and providing the staking power for the entire network. Is almost it's basically the same like Ethereum 2.0. It's the same like all the POS network like Avalanche, BNB Chain, Polygon, and many more. So a portion of the transaction fee for cross-chain asset transfers and also networking fee will flow into the Celer stakers who are staking their token to provide the security for the network. And also the Celer is also used to govern the protocol upgrade and system parameters as well. So what our developers are building on top of Celer today? Like there are a lot more things that are building very exciting things like lending protocols that are you can collateral on one chain and borrow on another. There are NFT marketplaces where you can place bids on auctions that is happening on an entirely different chain. You can have yield aggregators where like you can just say, okay, I want to move my fund to multiple different chains and kind of generate a yield without actually me going into those chains. And there are NFT bridges that are supporting multi-chain metaverse games. And there are cross-chain governance protocols where you can have governance decisions voted across many different chains and have the final decision propagated to all these different chains for multi-chain deployed applications. And there are many more that are being built by the community as well, which we're very excited to see coming up. So yeah, so that's a very, very quick introduction about what we are building. And this interchain message protocol and message framework is open source, and we have a full-fledged developer framework for you to build. And our developer is supporting in this hackathon. We hope to see you build on this platform. Thank you.